Hello everyone, my name is Peter Schaknat. I am Managing Director of Schaknat Electronic GmbH, and today we are optimizing a Scania R540. A few basic facts about the truck. It has a DC13 166 engine, 12.7 liters, common rail XPI. It originally has 2,700 Newton meters of torque, is equipped with an OptiCruise transmission, so it's a fully automatic 12-speed. The drive is 6x4, so it's a 3-axle again. And as I said, today I'll show you once again, in a straightforward way, how we optimize a 6-cylinder like this. So first we're going to read out the truck again with our Genius device. As we've mentioned before, we mainly work with the DIMSport devices. So now I'm going to log the ID first. Let's do that now. The OBD connector is down here. That's where the device powers on as well. Now we select the vehicle. Here it's the same again, the S or R540 or whichever, that's just the cab. What's important is the horsepower classification. 540 is the largest 13-liter engine or 12.7-liter engine. These engines come in 410, 450, 500 and 540 horsepower versions. Basically everything is the same. Block pistons, all identical. No one has it different, it's just been graded down. Again, it's the same here. With this engine, we actually don't add more than 60 horsepower so as not to overstrain the engine. If, for example, I had a 410 or 450, there would be much more potential. But as I said, it's also a 6x4 again. We also don't want to overstrain the drivetrain because it's probably going to be used for heavy-duty operations again. That's why, as I said, we do it this way, 600 horsepower and 3,000 Newton meters. That will be about the maximum. Alright, now let's select the vehicle. Let's look under Scania. Okay, now I'm scanning an R45. So, and as I said, what's always important for us, or at least for me personally, is the chassis number, software number, hardware number, and also the engine number. Because with our test benches, since Scania has a very low engine position, based on the software versions that we have already measured and tested on the test bench, we can also set that up on site without the car needing to be on the test bench. The way we are doing it now is exactly how it works in the field at the customer's location. Here you can see we have the hardware number, version number, software number, engine number, along with the chassis and everything else. So it's like the DC13 engine, as I mentioned earlier. Basically it's the largest in the 6-cylinder series. After that, the 8-cylinder engines start with a 520 or the new models as 530. I'll save the data set now, right now. Alright, perfect. We've basically read it out again, and now we'll go to the laptop and program it like this. We've basically read out the software now. Don't be surprised why there were still plastic bags everywhere, and the truck looks brand new. It has a completely new software version with brand new hardware and software numbers. This is already the 299 series in terms of software version. We've already tested a slightly modified generation of this software on the test benches as well. I've now successfully imported the data into the program, loaded up the original file, and already prepared something in advance. Now for the truck, we're going to carefully change the most important things, such as torque, the smoke limiter, a bit of injection timing, and also the injection quantities. In general though, we base ourselves on the standards the manufacturers use when programming among themselves. So I don't really need to increase the boost pressure if the manufacturer doesn't do that between the different power classifications either. So basically we don't do it either. but primarily this is about fuel consumption now. So what's important in optimization is that the truck performs well at low revs, so it can upshift early. As I said, it's a very simple formula again. Every revolution needs fuel, so keep the revs low. That means less fuel is consumed. Now, for example, as you can see here, we can clearly see the torque curve right here. You can also see the software here with a curve that shows exactly what it looks like in this context. Down here, you can see the RPM axis. And now, for example, I can go in here, where the green line that you see is actually representing the original curve, and I can individually and precisely adjust the values for the customer if needed, in terms of torque specifically. So, based on the software versions, I can always see what we've already tested on the test bench. That's what we always use as our reference, so that we can set the most optimal torque and the most efficient, optimal fuel consumption for the customer precisely. That's basically what it looks like. I'll show you a torque curve. Everyone can relate to that. If I show any specific diagrams, I can actually relate to them the least myself. Mainly the torque curve, that's easier to understand. When everything is completely finished, I carefully recalculate the checks again, double checking the software number, hardware number, and engine number in the software myself. To make absolutely sure that no errors occur during the flashing process, I load it back into the Genius device. Then we head back down to the IKW and program it in as the final step. We're flashing it back on now, that goes pretty quickly, and then we connect to the OBD again. Then basically I select the vehicle again and again the scanner, just as we did when we wrote it. Here too, it's the same with the flashing process. When we have all the data sets, we always flash in sections, so-called partial flashing. That takes about 2 to 3 minutes, so as you can see, it still goes pretty quickly because we're only flashing the areas that are relevant to us, meaning just the individual sectors, where things like torque, injection timing, injection quantities, all the lambda corrections, everything that's important to us are stored. We only flash these sectors. So that can SR540. Alright, the truck is programming now. As I said, we're basically done at this point with the optimization. I'll also teach in the transmission. For this customer, it's also about, I'd say it's more about comfort, making sure the shifting is smooth and that it engages the gears cleanly and softly, so that we relieve the drive shafts as much as possible, since they have to handle a lot of heavy starts. In stop-and-go situations, we basically program everything to minimize wear. Alright, I'd also like to go ahead and tilt the cab for you and explain the engine to you once more, just to make sure everything is clear. And as I said, then we're pretty much done. See you in a bit. We've now finished and optimized the transmission. Now we've tilted the cab once more. I just wanted to show a few more things in case you're interested about the Scania engine. As you can see here, it's a straight 6-cylinder engine. It's a pure common rail engine, so it has 6 fuel injectors installed. Scania operates with a very high fuel pressure, up to 2,500 bar. Personally, I don't touch the fuel pressure because I'm always worried about it because of the high pressure pumps. That something might break in the rail pressure system. I always handle it differently, but it's still actually efficient via the rail pressure. Scania already runs at very high pressures, which is why the trucks are relatively fuel efficient straight from the factory. Up here you can see the rail pressure bar where you access the individual injectors. Down here you can see the engine. With the whole Scania engine, you have to say they're simply straightforward. It's built in a way that makes it easier for workshops to repair. You can easily reach everything. As I said, the engine also has... The old engines had a rigid shaft for the turbocharger. This one already has a ball bearing turbocharger. As mentioned, it's also much better in terms of efficiency and wear. The truck doesn't have exhaust gas recirculation. So the old models had the 94 series Scania, for example. 6-cylinder, they still had 2-stage exhaust gas recirculation with that blue and particulate filter. This one is SCR only. So here, as mentioned, you just have the SCR system with AdBlue injection. so there is no exhaust gas recirculation on the engine. Scania installs that in the new models. All of them without exhaust gas recirculation. Most manufacturers do use exhaust gas recirculation. Personally, I'm not a fan of EGR because it clogs up the whole engine with soot. I mean, obviously, exhaust gas recirculation is basically burnt gas that is being recirculated. If you do that at the wrong temperatures, you can end up sooting up and gumming up the engine components. As I mentioned, we can take a quick walk around and have another look at the exhaust system. You might need that because of the exhaust gas recirculation. Since they don't have exhaust gas recirculation, they just use a bit more AdBlue. That's just how it is, but I'd rather use a bit more AdBlue than have exhaust gas recirculation. Here you can see the turbocharger. You see that's quite a hefty chunk as well. It runs with positive pressure, depending on what you set, 2.5 to 2.6 bar. Diesels generally run with a relatively large air surplus anyway. So in general, we don't change the boost pressure because there's really no need to. In terms of efficiency, when we add 60 horsepower to the engine, we also save on average about 2.5 to 3 liters per hour on this model with those weights. Here's the exhaust system. You can see it right here going down from the exhaust. As you can see, it's pretty cold. In the past, exhaust systems from other manufacturers were larger. They tried to compact everything to reduce weight. In general, the 6-cylinder engines from Scania are at the present time the most fuel-efficient engines on the market compared to Mercedes. Based on the susceptibility reported by my customers, I have very few issues or problems. At the moment, replacement procurement is a huge problem everywhere, in Europe or worldwide. So when it comes to electronic components and such, every manufacturer is having difficulties. But knock on wood, things are working quite well with Scania. Back here you can also see this is Scania Optigross. Here the transmission is flanged on. This is the old TMS2 transmission. This is actually my favorite transmission because I am able to fine-tune it perfectly in terms of adjustment and precision. I can really cater to every customer with it, making sure it meets their needs exactly. Depending on what the customer wants, as I've said before, whether it's comfort or performance, or depending on the needs, you can really customize the transmission to the engine individually. If you're interested in this topic of engine optimization, I can show you that on the R45. Feel free to contact us or send us an email at www.schaknat.de. I'd look forward to some interesting conversations. Or emails are welcome too, we'll answer those as well. You'll also get free advice or a free consultation. Thank you for tuning in. Thanks. See you next time. Ciao.